Before we dive in and do the class experiment today, which I'll have to find a video of on YouTube because I'm not recording us in class doing an experiment. Before we get into all that, I know yesterday when I was meeting with my small groups, there still seems to be some confusion with what I think is the most three basic but most important words of this entire unit, and that's conduction, convection, and radiation. So we kind of sat down and everybody said, I get the three mixed up a lot. And I understand that. I mean, unfortunately, two of them start with a C. That's kind of hard to do. And if you start flipping one or two and you get all of them wrong, like you're going to miss a lot or over half of the questions like we did in my small groups yesterday. So we need to kind of talk about that. So I came up with this, what I think is a very cheesy way to remember these three things, but it's the only thing I could think of. I searched the internet for a while of any tricks or tips or ways to remember it, and the only thing people kept posting was the actual definitions. I'm like, that's not a trick to remembering it. That's knowing the definition, which is good, but I don't know. If you're getting them mixed up, hopefully this will help. I talked to Alishba yesterday, and she said that this made a lot of sense to her. I'm hoping it makes a lot of sense to some people in here. Because again, conduction, convection, and radiation is going to be 80% of the test questions, right? Which of the following is the best example of radiation? Somebody sits beside a campfire. That is most likely what? A hot air balloon is a what? Boiling macaroni is this. Like, it's all those types of questions. And we'll see like two or three of those today in the review game that we play. But if you're getting them mixed up, I don't know. So we'll try this out. We'll see if it works. I hope it works for you. If it doesn't, I'm really sorry. First, we got conduction. So you'll notice that I highlighted the D in a different color, underlined it, and then over beside that I put do not, because of the D there, do not touch the hot stove. So we all know that conduction is the transfer of heat through touch. Transfer of heat through touch. I'll give you a moment to get that copied down. Right. I know that's really pushing it with the quote-unquote arrows. It works. Convection, where you have a red arrow going up. You have a blue arrow coming down, which looks very, very similar to that convection cell that we've talked about a lot, where hot air or hot water rises. Cool air or cool liquids sink. That's going to be the crux of the experiment we do in class today. Convection is a transfer of heat through a gas or a liquid. I don't want to do that in blue. transfer of heat in a gas or in a liquid? Give you guys some time to jot that down. Obviously, we had conduction, convection. The last one that we're going to have is radiation. I'm cheating. I'm terrible at drawing fire. Radiation. Heat from the sun or a fire. How does heat move in radiation? It moves through waves, heat waves. Heat moving through waves. Conduction. We cheated and underlined the D and highlighted in red and said do not touch the stove. So we know that conduction is the transfer of heat through touch. Convection, we changed the N and the V into arrows. It works. Sort of. Hot going up, cold going down. That's the transfer of heat through a gas or a liquid. And now we have radiation, where I changed the A's to a sun and a fire. And you have the heat from the sun or a fire. And how does that heat move from the sun or from the fire? It moves through heat waves or electromagnetic waves. If you remember, it moves through waves, and there's no touching involved at all. There's no gas, no liquid, no particles, just heat waves. You will be fine. Now that we've all got to see that experiment, when we start our project, which, by the way, for the people that are at home, have we started it? No, I know it says start and work on the project. The snow days and all that, we're just pushing things back. I promise I'll let everybody know when we start it. But we just did an experiment. We had 2 jars. Again, I would put this in my project because it makes sense. And we had one filled with hot water. And I had one filled with cold water, right? Again, I'm not coloring this in perfectly because this is not a project I'm turning in. This is what I'm putting in my notes. Now, I took those 2 jars, and to show you convection, I put them on top of each other, right? So I took 1 jar. Let me make sure I go back to my pen. And I put it on the bottom. And I took another jar. And I put it on top. What jar, for most of the groups in here, what jar did I put on the bottom? For almost every group in here, Veda. The hot one. I put the hot on the bottom because we know that hot rises. Hot air, hot water rises. And I put the cold one on top. So at the very, very beginning of the experiment, it looked just like this because I had like this little bitty card right here, right? I pulled the card out. What did we see happen in this convection experiment, Jesse? It did. So what would explain the convection cell? What was going up? You could see the hot going up, and you could definitely see this because this is what you could, because the blue is so much darker colored. You could see the blue going down. Now we had 1 jar that was really cold to the touch, the other one that was very hot. Trust me on that one.
Mr. Fuller?
Yes, ma'am. Yes.
I need Collins Parrish for a checkout, but she will return.
You got it.
Thank you.
And when I pulled that card out, we noticed that there was this transfer of heat energy. The hot was rising, the cold was sinking. The hot was rising, the cold was sinking. And it did so until our jars ended up looking like, yes, I know my jars are terrible, but not even worried about it. Our jars look like, not that color, like this at the end, didn't they? Because the water and the temperatures had mixed evenly. As a matter of fact, when we got done and touched the jars were the same temperature. Because heat had moved from the hotter object to the cooler object until they were both the same temperature. Now, there was one group that I kind of messed with to begin with. And when I say messed with, I mean I made a big mess and I was messing with them. Thank you for cleaning that up for me. I took theirs and I had theirs set up a little bit different. I had theirs and it looked just like this. And when I pulled the card out, what happened? Nothing. Why did nothing happen? Because the hot's where it wants to be. The cold is where it wants to be. Now, if we were able to really get on a molecular level, yes, there was a minor amount of change in this area. You could see it slightly, but it wasn't until I flipped it over that you could start seeing the convection cell. And it probably would have stayed fairly true to that until the heat was lost through the jar to the air around it. That's probably where the heat would have been lost to. And the bottom jar would have been picking up heat from the desk at the bottom. If we could really see it, like, that'd be kind of cool if we could look at it that way. Fun experiment, right? Again, for the people at home, if you're watching this video, it's a very boring way of seeing it, but I'll also post the video of the convection in water. And if I don't have one, I'll make one after school, but I'm pretty certain there's got to be one on YouTube. Anyway, any questions before we move on in class? Everybody good? Who feels a little bit better about conduction, convection, and radiation after today? I know I do. Now we're going to play a review game. A lot of fun. Don't get mad at each other. I'll post the review game for the folks at home. Smash the like button and subscribe, and we will see you later.